Alright, the last problem for this review is problem number 19 on page 415. Page 415, number 19. Problem reads, a New York Times article noted that the mean lifespan for 35 male symphony conductors was 73.4 years, in contrast to mean of 69.5 years for males in the general population. Assuming that the 35 males have lifespans with a standard deviation of 8.7 years, use a 0.05 significance level to test the claim that male symphony conductors have a mean lifespan that is greater than 69.5. This is our claim. Have a mean lifespan that is greater than 69.5. Significance level we are using is a 0.05 significance level. The sample size, N, is 35. The sample mean, conductors have a mean lifespan of 73.4 years. The sample standard deviation for the conductors is 8.7. Alright, so we're testing the claim that the mean is greater than 69.5. Opposite of our claim is mu is greater than or equal to, we just write equals to 69.5. This is our alternative hypothesis, our null hypothesis. Again, the population standard deviation is not known, so we're going to use the t-test to test that claim. So we hit stat, test, t-test, and we're going to enter the stats. The value of our null hypothesis is 69.5. X bar 73.4, S is 8.7, S is the sample standard deviation, N is 35, and the value of the the inequality in our alternative hypothesis is greater than, so that's what we should have highlighted, and then hit calculate. Now we've got our test statistic and p-value, 2.65. And the p-value is 0.00603. So now we compare our p-value to our significance level. This p-value is less than the significance level, therefore we reject the null hypothesis. We write our formal conclusion. There is sufficient evidence to, our original claim is the alternative hypothesis, so we write support the claim that, restate the claim, mu is greater than 69.5. And again, to find our critical value for t distributions, we're going to use t interval. So we pull up our calculator, stat, test, t interval, and we're going to enter 0 for the sample mean. And when you're trying to find the critical value for a t distribution, you use 0 for the sample mean. For the sample standard deviation, the square root of the sample size, square root of 35. The sample is 35, and now our critical value is in the right tail. Therefore, we're going to use 1 minus 2 times alpha for the confidence level. Alpha is 0.05. 2 times 0.05 is 0.1. 1 minus 0.1 is 0.9. So we're going to enter 0.9 for the confidence level. Hit calculate, and the critical value is in the right tail, so we're going to use the positive critical value, 1.69. Alright, so we're all done with the review. Hope you enjoyed it. Have a nice night.